Okay, yes, everyone. Is my voice audible to you all?
I cannot see all of your messages. Okay, now I can. So did your practice during the weekend time for the binary search? Yes, guys, any responses? Yes, no on the chat boxes. Okay, a no, 2 yes. What about the remaining people who have joined in the class? Yes, guys, you can be quick. Yeah.
Yeah, ma'am, I practiced, but I am getting some errors.
Okay.
Uh, yeah, in some test case. Uh, it will take 2 minutes. Can I share my screen?
Right now you can't. At the end of the class you can.
Okay.
Okay. Vaibhav, you didn't practice. Okay. Vishnu, you didn't practice. What happened to you guys? And what about Rohit, Mani, Vipin? Someone has joined with Vivo name. I'm not sure who is the one. Kishore, Mohan, Madhuri. What about you guys? I was not well. Okay. Let's start on with today's session, and we can also have a practice session on binary search so that you all can practice well. The question for today is you have been given an array of n numbers, that is 3, 5, 10. It is a sorted array, as you all can see, 20 and 23. Another one is -4, -2, 7, 11, 13, 14, 16, 17, and 18. These are the two arrays given to you, and you have, like, you all can see that both are the sorted arrays. Yes or no? Yes. And now you have to tell that if I merge both of these arrays and the third array generated, sorry, this is of size m, the third array generated, which contains both of these numbers, should also be sorted, and you have to return the mid element of the combined sorted array. Everyone getting this? Okay, that's great if you all are getting it. Yeah, mid element in the sense, let me just do that thing as well. If I merge both of these arrays, I will write it as -4, -2. Then it will be 3, 5, 7, 10, 11, 12, 13, 14, 16, 17, 18, 20, and 23. Correct? This will be the merged array. Yes or no? And now, if you all can see, the indexes are in this manner. And if you try to find the middle element of this, what will you get? This one? Yes. Hence, you have to return this particular number as your answer. I hope now the problem is clear to everyone. Okay, that's great. So can anyone tell me how can we merge these two arrays?
Yes, ma'am.
Yeah, you can write down your approach in the chat box. Guys, I'm giving you all like, okay, my voice is properly audible to all, right? Is it? It's not feeble and all. Okay, that's great. So now I'm giving you all 2 minutes of time or 5 minutes of time. Think of the approach and then give your answers in the chat boxes, and then we will discuss the solution. Okay, I got one answer. What about the remaining people? Okay, so here comes one technique which we call it as, and it is known as a two-pointer technique. Okay, Bhuvnesh, you have done the same thing. I'm just naming it as two-pointer technique. Okay. Yeah, we can do that, Vishnu, but that will be too big, right? We obviously know that the first thing we have to do is to create a result array. And its size will be n plus m. That's for sure. Now, we all know that these two arrays are the sorted arrays, yes or no? Yes. So we will place our pointers in these two places, the first numbers of both the arrays, okay? And now we will see that among these both two numbers, which one is bigger and which one is smaller? I am pointing it as P1, the index I am saying, and I am pointing this index as P2. So the number at P1 index is bigger or the number at P2 index is bigger? The number at P1 index is bigger. So I will write here a condition if array of P1 is greater than B array of P2. If this is the case, that means the number in your B array is smaller and you need to attach it to your result array, correct? So you will write here, you can take another variable. I will say it as k equals to 0, which is denoting the indexing of the result array, okay? And I will write here result of k is equals to B array of P2. Is everyone clear with this particular statement? Yes, no? Okay. Now you know that B array -4 is taken and now we have to move our pointer to -2. Yes or no? Vaibhav, what I'm trying to say is you placed your first pointer at P1. That is the first number in the array A. And next you place your second pointer at -4, which is the first number in the B array. Is that clear? And we all know that the starting numbers of both the arrays are the smallest one, correct? Okay, so what I'm doing is I'm comparing both the starting numbers. The one which is smaller, I am assigning it to the result array. Clear? Okay. Now already this P2 index is taken. So we have to increase our P2 array to P2 plus plus, correct? Yes or no? And
Ma'am,
next we,
I have one doubt here.
yeah.
So when I'm saying P1 and P2,
Mhm.
um, to break it into smaller step, we have two for loops where one for loop goes from P1 equal to 0 to Pm, and another is P2 which starts from 0 and goes until M. And those two for loops, inside that, these operations we are doing. Am I right?
No, you are not. As of now, we only run up this loop until, let me just write it here, while either your P1 is still less than N, okay? That means it is less than the length of this particular array, and P2 is less than the length of this particular array, that is M. If one of the condition fails, that is if P1 gets completed or if P2 gets completed, we need to get out of the particular loop. Is it clear, Vishnu? Okay.
Yes, yes.
Okay, that's great. So we need to increase our this P2 plus plus, and the next thing is we had our result array, right? In the result array, guys, first listen to me and then say yes. So in this result array, I stored -4. This index is occupied, that is the 0th index. So I need to move my k also na, to the next index. So I will increase my k to k plus plus. So this is the entire thing we have to perform. Everyone clear with the first step? Okay, that's great. Now the next step can be, there can be chances that your A of P1 can be smaller. That is, I can write here A of P1 is smaller than B of P2. Yes or no? Yes. So here we can write that result of, again, I will just repeat the same stuff. Result of K is equals to A of P1. Here you will increase your P1 plus plus and then K plus plus. Clear, everyone? I have just repeated the same thing for the other condition. Now, yeah, you can just close your while loop. We will see how it is working so that we can get a better idea. So for the very first time, I will just write down all the values. P1 is at 0, P2 is at 0, and K is also at 0. Okay. So when you are comparing the first numbers, 3 and -4, which one is smaller? -4. So we stored -4 in our 0th index of the result array. And then we will increase the value of K. K will become 1 and P2 will also become 1. But P1 remains 0. Correct? Okay. Now on the next step, when again you will compare, which numbers will you compare? You will compare 3 and -2. So which number is smaller, 3 or -2? -2 is smaller. So here -2 will be stored. Again, your P2 will increase to 2 index and your K also will increase to index 2. Your P1 is still remains at 0. Clear to everyone? We will see the next iteration and now we will compare 7 and 3. Which number is smaller? 3. So 3 will get stored here and now you can see 3 is from array 1, that is A array. So P1 will increase this time and it will become 1. P2 remains as 2 and K will now become as 3. Clear? Next time you will compare 5 and 7. So among 5 and 7, which is smaller? 5 is smaller, so we will store 5 here. And again, we will increase our P1 value. So it will become 2. P2 is already at 2 and K will become now 4. Now we will compare 10 and 7. Which one is smaller, 10 or 7? 7. So we will store 7 here and we will increase the value of P2. So here it will become 3. Your P1 will remain as 2 and your K will now become 5. Getting this, everyone? Now we will see here that it will compare 6 and my bad. It will compare 11 and 10. Which one is smaller? 10. So it will store here 10. And now the P2 value, the P1 value is again increased. Both will become 3, 3. And here this will become 6. Everyone getting this part now? Is anyone in the class confused about what I am discussing? No, okay. Clear, that's great. Now we will see 12 and 11. Which one is smaller? 11. So we will store here 11. 11 is in the B array, so P2 will increase to 4. This will remain as 3 and this will become 7. Now we will compare 13 and 12. Which one is smaller? 12 is smaller, 12 will get stored. And now we will increase the value of P1, it will becomes to 4. Here 4 is there and here it will become as 8. Now it will compare the value of 20 and 13. Which one is smaller, 13 or 20? 13. Now here your P2 will become 5, this will remain as 4 and this will make it as 9. The next time again it will compare 14 and 20. Which one is smaller, 14 or 20? 14. So here we will get 14. We will again increase the value of P2 to 6. This as 4 and here it will become as 10. The next time it will come, it will compare 16 and 20. Which one is smaller? Sixteen is smaller, so this will again increase to 7, 11 and 4. For 17 also the same thing will happen and 18 also, right? Because both are smaller than 20. So I'll directly write here. Everyone clear so far? Everyone clear so far? Okay, great. Now you all can see we have reached the end of this particular array, B array, yes or no? In this case, we will get out of this while loop because this condition will fail that P2 is less than M because now P2 will become equals to M. Yes, all of you are getting this. Okay, that's great. So now in this case, when it will get out, we still know that there are few numbers left in array A. Yes or no? Yes. So for that additional case, we need to write here while in case that P1 has still not reached till N, we can write here while P1 is less than N. Until then, you can just keep assigning the values that result of K is equals to array of P1. Then you can increase your P1 plus plus and then you can increase your K plus plus. Clear? Same thing can happen with your other array as well. So you can write the condition for that as well. Guys, just give me a minute. Yes, Vaibhav, you can tell me what's your doubt is.
Hello. Yes, ma'am.
Yes.
Yeah. In a first loop, we have written that P of n and P of 2 of m. Okay. If both the conditions are true in while, then only it will move out of the loop, right?
It will
But
move into the loop.
okay. The okay, fine.
Clear?
Okay.
Ma'am, what if value of P1 and P2 value matches at some point? You can see here, Mohan, that it has matched several times. You can see this particular instance, 4 and 4. Acha, you are talking about the values. Yeah, then you can keep here a condition for your cases. In any one of these, you can keep less than or equals to or greater than or equals to. It will be handled. Everyone, did you got Mohan's doubt? Yes, Mohan, did you got the answer for your question? Okay, great. And others, what about you? Did you got his doubt? Here, I'll just finish up the code. Okay, that's great. And again here, K++. And I hope you understood these two while loops, which we are writing outside the main while loop. And then you can close your main program. Everyone, are you clear or not? Okay, that's great. Now finding the mid element is not tough. You have your n, you have your m, divided by 2 will give you the middle element, like the middle index. And then you can return the answer as result of middle element. Yes, everyone is clear now? Everyone, are you clear? How are we doing this stuff? Okay, great. So you all can see that we are at least running through entire first array and the second array. Yes or no? We are running through both the arrays. So we are total covering n plus m distance. Yes. Hence, that makes the complexity of this particular program. Clear? I hope you are clear with the complexity part, because you can see we are traversing on the array one time, like maximally one time. So one time we traversed on first array, one time we traversed on the second array. That makes its complexity as n plus m. Anyone having any questions here? Yes, no, anything? No, okay. Guys, just give me a minute. Okay, is there any other way we can solve this particular problem? Anyone thought of that?
Ma'am, I was thinking that we can interrupt instead of going all the way from n plus m
Mhm.
to the middle, like n plus m by 2, in while we are doing the while.
But Vishnu, n plus m by 2 is almost equals to n plus m. Like there is no much difference in the complexity.
Oh, okay. Yeah, I got it.
Others, what about you? Any other way we can go through, because you can see the arrays are sorted. Some way we can apply the binary search and all.
Another thing I was thinking is
Mhm.
like start with middle element of both the arrays.
Start with middle element of both the arrays. Okay.
And you reach to a point where they are like middle of the resultant array.
But okay, let's just take this idea. Here is your array. I am saying it is of 100 elements. So you know middle will be at 50th index, or you can say
Correct.
49th index, right? And the other I am taking only one element is there, that is 10. Now,
Oh,
or let's suppose I make it as 1000, then you have to traverse up to 500. So doesn't make any sense, right? Anyways, you have to traverse.
just 1 second. So if it is 1000, I'll let's say pick up the 500th element and then compare with the B1.
Yeah,
And
okay.
if it is low, then 500th element is the middle element. If it is higher, in this particular scenario, the B1 would be the middle element.
No, it won't be.
So you see, 1001 would be the grand total.
Mhm.
So technically, it will be 501th element would be the middle element. So all my goal is to get the 501 element of these two.
But you don't know that where you are going to fix this 10.
I didn't get you. Fix the step
See,
means,
this particular array is sorted, right?
yeah,
This is also sorted.
yes.
And you have to give your middle element after joining both the arrays, and that too in a sorted manner, right?
Okay, okay.
So you don't know whether this 10 will be inserted before the 500th element or after the 500th element.
Yeah, I'm sorry. Then this will not work then.
Yeah. So this is not gonna work. Now just look closely to the question that I gave you. I'll just write the both arrays. Your array of n was 3, 5, 10, 12, 20, and 23. Your B array of m is -4, -2, 7, 11, 13, 14, 16, 17, and 18. Yes. So if you notice, this 12 was the one element which you were getting as your answer, right? When you were combining both the arrays, you were getting 12 as your answer. Yes or no? So if you notice here, if I just combine these arrays, -4, -2, 3, 5, 7, 10, 11, just make it highlighted one, 12, 13, 14, 16, 17, 18, 20, and 23. So this is our middle element. Yeah, there are exactly 7 elements which are smaller, or you can say less than 12. And there are exactly 7 elements which are greater than 12. Everyone, are you able to follow this part? Okay, that's great. So now, why don't we just keep our high and low values as our the minimum value and the maximum value possible in the array. And then just try to find out, like all the time, you just take a low value, okay, and a high value and find out a mid. Okay. And for that particular mid, find out how much numbers are less than this mid and how much numbers are greater than this mid. If at any point they are equal, that means that particular number is going to be your middle number. Yes or no? Is everyone able to follow this?
Ma'am, I have one question.
Mhm.
Even the sum of n plus m is even number. Like for example, if it is odd, I mean, I'm thinking that let's say if there are four total elements, then either two or three both could be possible. The mid is in case of an odd number, it is okay. There is a single odd middle. But for even, like for example, four, it could be two or three. So how do we find out which one is the mid element?
Just take the half of it. 4 divided by 2, 2. That's it.
So, but is it technically correct because
Mhm.
of that, because two has one element to the left and two elements to the right?
You can handle that case, right?
How? I mean,
Like
just
here, I am saying that you can just check if the number of low elements and the number of high elements, like
Mhm.
greater than mid and lower than mid, if they are coming out to be equal, then in that case, this is your answer, right?
Correct.
But in that particular case, you can check now that if the number of elements which are greater than mid are plus one, then the number of elements which are lower than mid.
Correct.
That can be your answer. Like we can modify it, but I'm just asking for the possibility that whatever I'm saying right now, is that an approachable solution? Can we move in that direction? Will it work?
Yeah, yeah, it will work. Yeah,
Everyone
that's
else in the class, I want your opinions as well. That I just said a solution which we can see as a like possible solution, but is it gonna work? Or there are certain drawbacks for that? And I want you all to think of that and tell me. I'm giving you 2 minutes of time. And all those who are not clear with what I just told now, you can just tell me. I will repeat my answer once again. Okay, Mohan didn't got it. Okay. 3 people has not got it. Guys, what I'm trying to say is that you all saw here that whatever your middle element was, there were exactly 7 elements less than 12, and there were exactly 7 elements greater than 12, right? Okay. Now I am trying to say here is, can't there be a way you can just take your low number as the low among the first numbers? Like let's suppose I take my low as -4 and my high number as the maximum among the maximum number in both the arrays. So I will get my high as 23. Considering these two numbers, I find out my mid. If I find out my mid here, I will get it as 23. Sorry, it is high plus low divided by 2. So -4 plus 23 divided by 2, I will get somewhere around 10. Yes or no? So here is your 10. How many numbers are less than 10 here? 1, 2, 3, 4, 5. Okay. And how many numbers are greater than 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So this particular ratio is not equal, right? This varies. The number of smaller elements are 5 and number of bigger elements are 9. So this is not our answer. Everyone able to follow this? Okay. In this particular case, what we need to do? If this is the case, what we need to do? No. If your number of less elements are smaller, then you should be moving your low, right? You should be moving your low to mid plus 1, correct? I hope you all got it. Now, if I moved my low to mid plus 1, my mid was at 10. Now it came at 11. Yes or no? Okay. So I got my low as this. That is 11. My high was still at 23 divided by 2. So I will get here 34 divided by 2, that is 70. Yeah. So how many numbers are there which are smaller than 17 and how many numbers are there which are bigger than 17? The number bigger than 17 are just 3. And the numbers smaller than 17 are 11. Again, the ratio is not valid. Yes or no? Okay. Now what should we move? If the number of higher elements are smaller, then what should we do? We should move our high to mid minus 1. Now your high will become as 16. Yes or no? Now we will check how many number of elements, sorry, low plus high divided by 2. Your low was at 11. Your high is at 16 divided by 2. 27 divided by 2, you will get it as 13. So how many numbers are there which are greater than 17 and how many numbers are there which are smaller than 13? Sorry, not 17, 13. Guys, be quick. It's 8 and 6, not 7 and 6, it's 8 and 6. Again, it is not equal. Still, your higher numbers are smaller. So you will again move your high and you will move your high to mid minus 1. Your mid was 13, mid minus 1 will become 12. Everyone, are you able to follow this? Okay, now when you will do 11 plus 12 divided by 2, you will get here 12. And now you will notice that the number of elements on both the ends are equal. And hence you will give your result accordingly. Is it clear to everyone? Are you getting how we are deciding our boundaries in this particular question? The remaining people in the class, are you getting how we are setting our boundaries? I cannot see any one of your answers. Is the class has been that much heavy for today? Okay, I'm allowing you all, if you have any doubt, you can just unmute and clarify it as quickly as you can. Okay, let me ask.
I have a small doubt, madam. See,
Uh,
even though, can
yeah,
I
yeah,
say?
correct. Gaurav,
So,
there will be one more iteration. Just a minute, Vishnu. Here it won't give 12, it will give 11 only. But when it will check for 11, it will fail. So it will increase its low again to mid plus 1. So both will become 12. And that point you will get your answer. Okay, that was one step I forgot. Yeah, Vishnu, you can continue now.
ma'am, since you know the approach, it's very easy to hit
Mm-hmm.
the thing.
Mm-hmm.
Uh, and it is very hard to think if we don't know the approach.
See, Vishnu, the thing is that if I don't introduce you all to these new approaches, then you won't be knowing it ever, right? Because like waiting and thinking for these kind of approaches will be like that we don't even know the topic and we are just thinking to get an extraordinary solution. Are you able
Oh,
to follow? So
yeah.
at least there should be a slight push in that direction, right? That now I have told you binary search in so many ways that sum of pairs is there, floor is there, seal is there, frequency of a number is there. Today, this particular problem is there. So when you will get some problem in future ahead of you, then you will think in that perspective, right? That can I apply a binary search over here? Are you getting my point?
Yeah.
So in our classes, basically, it's not about that I'll say that okay, I'll just give a question and I'll say okay, just give me the optimized solution, because I know that right now you all are in the learning stage and you just started to get on with the topics. So slowly when you learn all these things, okay, this can be done in this particular way, then in the future when you will be solving a question, it will be helpful. Clear?
Yeah. Thank you.
Yes. Anyone else in the class who has any questions regarding this particular approach? Even though the first approach that we discussed was good enough for an interviewer, but you should be well prepared with the other approaches as well. Okay. So, okay, no one is having any doubts or questions? I'll wait for 2 more minutes. Let's see if someone. Give homework. Okay. Okay, I'll give the homeworks. There are lots and lots of binary search problems which I can give you all as an homework. But as of now, today you just go through once again with this particular problem. That will be enough. You all can notice here that all the numbers that we were getting, no matter on low or high or the middle element, were present in the array, right? But what if the middle value that we are getting is not actually in the array? So just go take the test cases according to you and see if this particular solution is working. Ma'am, we are comparing total count of numbers with mid value. Total count of the numbers which are smaller than the mid value and the total count of the numbers which are greater than the middle value. And in this particular question, Rohit, our middle value is not the index, but it is the number itself. Okay, then guys, if you don't have any questions, okay. If the question is only to get the median of the two merged sorted arrays, then we get median of both the arrays and compare. Bhuvnesh, it's the same thing which Vishnu discussed, and I guess I explained that thing. That what if, okay, just see here. I'm just giving you And here I'm giving it as, okay, what will be the middle value that you will get when you are merging the two arrays? Just see the two arrays that I have written now and tell me the answer. Complexity here is log of maximum value minus minimum value. Because you are only, if you notice, your boundary was the minimum value that was -4 and the maximum value which was 23. So it's basically log of max minus min. There is no n and m required here. Which question, Aman, are you talking about of the binary search? And Bhuvnesh, can you tell me the middle element which I just wrote, like the arrays which I just wrote? Accordance to my logic, 1 will come. Okay. Because you are going to compare 12 and 1, right? But if you see overall and you are merging the array, what will be the actual middle element? Three, correct? Okay. Yeah, Aman, I'll be sharing the practice questions. As of now, you all can see the questions in the Hacker Rank platform. If you all have solved those questions, it will be great. Then I'll be sharing the remaining questions. Okay. So Bhuvnesh, I hope you got it that why cannot we go through your approach? Okay, it's wrong, my bad. Yeah. Okay, then everyone, thank you for joining today's session.